We're back! Brand new recording studio. Spent a lot of money on it. Okay, let's get rocking. So, we're on 6.5, trigonometric equations. We're going to start looking at graphing these bad boys. And we're going to start with sine x. Start with that one. Now, when we're graphing it, we're going to get a sketch right away. We are grabbing certain values from the unit circle. So if you're wondering where all these values come from, I'm basically just going to start over here at 0. Like 0 degrees or 0 radians, and I'm grabbing certain values here. So we're going to grab it at pi over 2 where we're 0, 1, and we're going to grab it at pi where we are negative 1, 0, and then 3 pi over 2, and the coordinate there is 0, comma, negative 1, and then 2 pi cycles back there. Okay, so we're going to be grabbing at those locations, and we'll be getting a sketch of sine x. Now just remember that sine x are the y values, all right? So they're the y coordinates of these points. So over here at 0 degrees, my y value is 0, so that's going to be my first point. And I might actually use a different color here, so there we go. All right, and we'll just label that 1 and negative 1 for later. Now, when we get to pi over 2, so let's label this pi over 2. At pi over 2, my y value is 1, so my sine function is at 1. When I get over to pi, my y value is 0. And when I get over to 3 pi over 2, if you check it out, my y value is negative 1. And then when we get to 2 pi, finally, we're back to y value of 0. Now you draw a smooth curve and you connect this bad boy and you get something that looks like this. Boop. So there it is, sine x. Beautiful, wonderful curvy graph. So check out the domain. Well, we can keep going forever and ever. We can keep going coterminal angles. So the domain is actually x element of the reals. Now the range, you'll notice, is always between negative 1 and 1. So that is what we're going to write there. Period is something that we're going to talk about in a moment. For now, we're going to write 2 pi. I can briefly explain. The period is how long does it take for the graph to form this shape one time. So we started at 0 and then we made that shape one time and it took 2 pi units, okay? This thing is cyclical, so if you keep graphing it, if you were to do it all over again, you're just gonna get the same shape over and over and over again. Same thing if you start going backwards, you're gonna get that same wavy looking shape. It takes 2 pi units for it to happen. The maximum value is 1, minimum value is negative 1. The amplitude is defined as the distance from the center line, so there's my center line, up to my highest value. So this is the amplitude, and as you can see, it goes from 0 to 1, so the amplitude there is 1. And intercepts, well, we got them at, where do we see, 0, pi. Okay, so it's happening every pi units, 2 pi, etc. So if I was to write a formula for that, I would say it's k pi, and k is an element of the integers. Remember that one because sometimes they ask for it on the exam. Wonderful. We did our sine x. Now let's do cos x. So here we go, cos x. Remember, these are going to be the x values on the unit circle. So refer back to this. Now we're looking at the x values. So here we go. Let's see if I can do it off the top of my head. Just going to scroll down a touch here. So at 0, we're going to have to label this 1 and negative 1. At 0, x is actually 1. When we get to pi over 2, the x value is 0. When we get to pi, my x value is negative 1. When we get to 3 pi over 2, we're back to 0. And when we get to 2 pi, my x value is back up at 1. So, without further ado, your cosine graph looks like this. And remember, we can keep going, so if we start using coterminal angles, we're going to get the same shape again. Okay, if we go backwards, we're going to get the same shape again. All right, maybe we can just do something like that, and then this would have been negative 2 pi. Okay, so let's start at the beginning. Domain, x element of the reals. The range, you're going to notice again, is still between negative 1 and 1. Period, still 2 pi. Okay, so this is the shape of the cosine graph. After that, the graph just repeats. So if I go backwards, I get the same shape from 0 to negative 2 pi, so on and so forth. Maximum is 1, minimum is negative 1. Amplitude, so if you look at the center line, which is here, and you go down to the lowest point or up to the highest point, you get an amplitude of 1. And then the x-intercepts look like this. Well, they're pi over 2, 3 pi over 2. So it's going to be, the formula is going to look like this. You're going to go pi over 2 plus k pi. And I mean, that's not obvious, so I'm giving it to you. So there you have it. That works. Let's just leave it at that. So there it is, cosine, know that one. And last but not least, we have tangent. Now tangent is extra weird because remember, tangent is the ratio of y over x. So the graph of this is going to be quite a bit less obvious, but it might be worthwhile drawing the circle for this one. So there's my unit circle. And we have the point 1, 0, and then 0, negative 1, and then negative 1, 0, 0, 1. Now, a couple things happen. When we go y over x, there are places where x is 0, right? Now, we don't want x to be 0 because we're going to get an asymptote because we can't have a 0 in the denominator. So let's go and find our asymptotes first. So right away, well, my x value here is 1, so that's okay. But when you get to pi over 2, you can see that you have an x value of 0 there. So when you go 1 divided by 0, you're going to get undefined. So at pi over 2, you have an asymptote. So I'm going to do my best to get a straight line here. So this is at pi over 2. Now, let's just jump ahead for a second to the next spot where x is 0. That's 3 pi over 2. So you get another vertical asymptote right there. What about the other spots? So at 0 degrees, when you do the ratio 0 divided by 1, well, you get 0. So there's a point there. Let's just go backwards for a second. So if we're going this way, this would be negative pi over 2. And that's another place where we get an asymptote, right? Because the x value is 0. So it might be useful to draw that. Now, we know this point here, and we have an asymptote here, an asymptote here. And in general, these graphs want to hug the asymptote. So we're just doing a sketch. So it turns out that the tangent function looks like that. So it's going to go hug that asymptote and go and hug that asymptote. Let's check out the point pi. Right now at pi, again, you got 0 divided by negative 1. So you get 0 again. So once again, it's going to go up and hug that asymptote, and it's going to go down and hug that asymptote. And that is your tan graph. Now at 2 pi, we know it's going to go down like that. And we didn't draw the next asymptote, but we know it's going to look like that. But there it is, your tan graph. Now, this one is going to be a little bit more interesting for domain. So we know that basically x is an element of the reals, except x cannot equal these certain points, pi over 2, 3 pi over 2, right? So one way to write it would be x can't equal pi over 2 times k plus 1, where k is an element of the integers, okay? Woo! Very nice. That's a pi. That's pi over 2. I don't know how well that came through. Let me try one more time. So it's pi over 2, open bracket. There we go. Okay, that's the domain. The range is essentially anything, right? So I can get any y value possible, so I'm just going to write y element of the reals. Now the period is a little bit different than before. So how long does it take for it to repeat this shape, right? This is the shape the graph has. So this is negative pi over 2 to pi over 2. That would be pi units. So every pi units, it repeats that shape. So the period is pi. Remember, period is how long does it take before it repeats that shape, okay? The maximum is essentially infinity, right? Because we go off to infinity. Same thing with the minimum. Now, we don't talk about the amplitude for tangent graphs. We just say they don't really have one because they go off to infinity. And then the x-intercepts, well, they have a pattern of going k times pi, right? So if k is 0, you get 0. If k is 1, you get pi. If k is 2, you get 2 pi. So the intercepts are k pi, where k is an element of the integers. Again, I recommend that you sort of memorize these little formulas because they do pop up on the exam like just once. So there you have it. You got sine, cos, tan. You got the graphs. What are we going to do with it? Well, a little bit of a blurb on what sinusoidal functions are, but basically we're going to be graphing them, and we're going to eventually be doing them with transformations. So all the transformations we did in the transformations unit, we're going to be applying to these functions, and that's where they start getting a little dicey. Luckily, I have a very easy way to graph them. They usually have a 4-mark question on the exam where you're graphing a sine or cosine graph, and with my method, you can guaranteed get 3 out of 4 with very little effort. So that's good news. Now, yeah, basically this little blurb, you can read it on your own, but a couple things to point out here is Yes, the maximum, it's important to know like the definition of the maximum. So the maximum value and the minimum value are equidistant from the center line of the graph. So say I got my sine graph here. So my sine graph goes like this. Now this one's real handy because right here, this is the center line. Okay, so the maximum of the function is defined as the distance from the center to the highest point, or from the center to the lowest point. That would be the minimum. This is also called the amplitude of the graph. So it's always from the center line. That'll be important later when we start transforming these. So that's what it says right there. Perfect. Let's get a couple sketches under our belt here. It says determine the amplitude of each function. So the amplitude is always the number out in front, right? And if you think about it, because you're going to be multiplying your y values by 3, kind of makes sense that this is the number that tells you the amplitude. So there's the amplitude right there. I'm just going to write amplitude is 3. And then for this one, the amplitude, is, now it says -1/2, but the amplitude is 1/2. So 1/2 is just, I should say, is the amplitude, okay? All right, let's get a sketch of each one of these. Now, for some quick practice, let's sketch the original graph. So for cos x, you're gonna wanna basically kind of memorize what it looks like. So it's just a sketch. So what you can do is, you know the shape. The shape looks like that. Okay, so basically I know that's 2 pi, and then I know half of that is pi, and then half of that again is pi over 2. This one plus this one gives me that one, 3 pi over 2. This is 1, and then we can just go dot, dot, dot over here. There's -1. So this is cos x. I did a pretty dang good job of drawing cos x right there. Now, we're doing 3 cos x. So I'm going to do that in red, fabulous. Now, I sort of don't have quite enough room, but all that's happening is we're multiplying our y values here, 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 and here by 3. So what happens to the amplitude? Well, the point at 1 jumps up to 3. So I'm just going to label it 3. This point here jumps up to 3. This point here jumps down to -3. So it's just a sketch. There, so that's -3. These points where y equals 0 just stay the same. So now when I do my sketch, it's going to look like this. And there it is, 3 cos x. So as you can see, center line didn't change. Amplitude is still from 0 all the way up to the maximum, which is 3. It's beautiful! Wonderful. Okay, now this one's going to be a little bit tricky. So let's draw the original sine x, and I kind of recommend you do the same thing. Now, I'm going to make it extra big because I know that my a value, my amplitude is -1/2. So I'm going to sort of say, okay, well, here's 1, and here's, -1. Perfect. So we actually start at 0 for sine, and we're going to just go wee, there. Now label it. 2 pi, half of that is pi, half of that again is that midpoint there, pi over 2, and then this one plus this one gives me that other point, 3 pi over 2. So we can see that I didn't do a very good job down here because I didn't get anywhere near my -1, so I might just resketch that. And that's okay. Bring an eraser with you. Eraser will be sort of your best friend. I might have to just restart the whole thing here. I'm gonna do my best to, there. Not bad, not bad. Here, we can always just move this. Haha, that's how the Italians do it. There, ha, perfect. So, now, we're gonna be sketching -1/2 sine x. So we know from transformations that when you have a negative out in front of the function, it's going to reflect, and then we're multiplying the y values by 1/2. So we're essentially multiplying by -1/2. So these points at 0, they're going to stay there, right? So 0 times anything is still 0. This point over here that's at pi over 2 and 1 is going to flip over and become -1/2 right here. So I'm going to label it. So there's -1/2. This point here at -1 is going to become +1/2. So there it is. There. So now I can see my new graph looks like this. Whee! And there is -1/2 sine x. Wow, that looks great. Wonderful. Perfect. Good job. Now, do they have questions like this on the exam? And the answer is yes. They will sometimes have just sort of an easy 2-mark, like do the transformation kind of thing. They generally have a big 4-mark question as well, but you do get questions like this in multiple choice and stuff like that, and short answer. So definitely good to know. Now, we're going to do a little bit of work with period. So it says determine the period of each function. Now, we didn't have a lot of time to talk about the period before. I sort of mentioned what it was. Okay, now there is a formula that gives us period. The period is given by this formula down here, 2 pi divided by b. That is the period of any sinusoidal function. Okay, now I already said that the period of sine x and cos x is 2 pi. When you start doing transformations to them, the period is going to change, and this formula is going to help you figure out what the period is. Okay, at the end of this slide, I'll get us to write a bunch of stuff. I will point out that what's this b term? The b term is the coefficient of the x term. So coefficient of x term. That is very important. And that is consistent with when we did transformations. Whatever the coefficient of the x term was, we called that b. So that is the same value there. So for this one, there is my b value. So when I go find my period, I go 2 pi over b. And I just plug in my b value. So it's 2 pi over 2. And if you can simplify, which you can, the 2's cancel out, you get the period is pi. So what does it mean? It means that if I were to sketch this graph, one cycle of sine would happen in pi units, okay? So this is what sine looks like. So that shape would happen one time in pi units. Very important for later when we graph them. All right. So here's my b value, it's 3 over 4. So when I go to my formula, I go 2 pi over b, so 2 pi over 3/4. Do the reciprocal, change it to multiplication, so it's 2 pi times 4 over 3. I get 8 pi, so I get 8 pi. The 3 doesn't go in evenly, so I get 8 pi over 3. Done! Last one. Now here I'm showing you this one because the b value got buried into the x a little bit here. So you can pull out your b value and you get 1 over 6 times x. So there's your b value. So the period for this one is going to be, oh my word, oh my word, oh my word. Just keep in mind that for tangent, it's pi over b. The period is pi over b. So if it's a tangent graph, your period is pi over b. So that's something to watch out for. Sometimes they mess around on the exam on that. So pi divided by 1 over 6, do the reciprocal. So you get pi times 6 over 1, and you get a period of 6 pi on that one. Perfect. Now, I want to write something down here. So I'm just going to pop over to the computer because it's a bit of typing. But it's very important that you know the difference between what the period is and what b is, okay? So remember, the period tells you how many units does it take to do one full cycle of sine or cos or whatever the base function is. What b tells you is how many times the shape happens in 2 pi units, right? So it's telling you, here's 2 pi units divided by b. So b is telling you how many times in 2 pi units you get, how many cycles you get in 2 pi units. So I'm going to write it out. Because it's one thing to say it, it's another to write it. So down here we go. So period is how many units it takes before the graph completes one cycle, i.e. like one shape, right? So example, p or period of sine x is 2 pi. B tells you how many cycles exist in 2 pi units. Here are some examples. So if you have sine of 2x, your b value equals 2. So there are 2 complete cycles in 2 pi units. I'm going to quickly go ahead and sketch that one, just to make sure that we're all clear. And if you think about your transformations, it should make sense. So this is sine 2x. Now normally sine would have one cycle in 2 pi units. However, if it's sine 2x, there's one cycle, and that would be pi units, and then we get another cycle, and that's 2 pi. So the b value is 2, and you have 2 cycles. 1, and then the second one is black. So there's 2 cycles of sine in 2 pi units. The period tells us how long for one cycle to complete. So if you look from here to here, so starting at 0 going to pi, that's 1 period, and it's equal to pi. So it only took pi units to do 1 period. There it is with this one picture. I hope you understand. And we're going to go do a couple more questions. So these ones, I don't know if we really need to do them so much. Can't seem to flip my page here, my goodness. I do have answers for you, so if you want to pause it and try it out, I'm just going to quickly write them very quickly. So if you want to pause and try, go for it. And I'm not showing any work. There it is. Okay. Yes, other transformations follow earlier rules. So we'll do a whole nother lesson on this, but I thought maybe today we would just look at one transformation at a time or so, okay? So right here, we got y equals sine x, and I'll go ahead and I'll do it maybe in blue. So here's sine x right here, if you want to highlight it on your page. Okay, you'll notice it's 2 pi and there's 0. Now, what should happen here? Well, we know that when you have a transformation in here, it's always the opposite sign. So I would take my xy coordinates and I would add pi over 3 units to the x values, and the y values would stay the same. So you can see here that we just added to all these points. So take those reference points that we always kind of graph. Can't quite see where it's at, it looks like about here. And we're moving them all over pi over 3 units. So this one moves here, this one moves here, this one moves there, this one moves there, this one moves there, and you get this new graph right there of x minus pi over 3, okay? There we go. So we say it's been translated pi over 3 units to the right. Well, we can do these ones here quite easily. It won't be too hard. No, it's just asking us what is the phase shift. Occasionally, quite often, that horizontal shift, what I like to fondly call the horse shift, it's also called a phase shift if it's a sinusoidal function. So stick that in your brain tank. So this one, what's going to happen? Well, we're going to go pi over 6 units to the right, so that way. And now it's saying, hey, can you sketch those graphs? It's sort of annoying to do it, but we certainly can. We can certainly do it. You sort of have to, actually no, let's leave it alone. For today, I'd be happy if you knew theoretically what happens. Let's not muck around with the units. When I show you how to draw these things, I have a perfect way to get the units and get the scale, no problem. So let's worry about that on the next lesson. This one here might be worth drawing a couple of these. So it says, describe how the graph of each function below relates to the graph of y equal cos x. Then on the same grid, sketch it. These ones are quite a bit easier to sketch, so I think we'll do it and we'll describe. So let's do all the descriptions sort of maybe above. So right here for A. So how does 2 cos x compare to cos x? Well, we just multiply y values by 2. So we would say it's like a vertical stretch by a factor of 2, you could say. B I'll do in black. So this one is cos 2 times x. So remember, your b value is 2. So normally what we'd be doing, well, it's still the same. We're going to be taking our x values and we're going to be dividing by 2. So that's what happens. What happens to our period? Well, the period is 2 pi over 2. So the period becomes pi units. So basically, we would have said this was a horizontal compression, and we're going to be squishing cos in. So how can we write that? Well, yeah, we can say, divide x values by 2, and you can say it's a horizontal, so a hor compression by a factor of 2. Last one, I guess we'll do in blue. So this is cos x minus 2. So this is going to be subtract 2 units from the y values. That's what's going to happen. All right, let's do it. Going back to A, this one right here. So we're multiplying the y values by 2. Now I sort of got this sketch of cos from the internet. What you might want to do is just, if you want to go like that and kind of go like that. So we know that this would be the point 1. So here's 2, here's 3, and then there's those important points right there, and yes, so this will be 2 pi. We can just label it up like this. Here's pi over 2, 3 pi over 2 right there. Perfect. So we're doing this one in red, and we are multiplying the y values by 2. So this one goes up to here, this one stays there, this one goes down to -2, and this one goes up to 2. So, and we're going to pass through those x-intercepts. They are not going to change. So here we go, and there is cos, or 2 cos x. Beautiful. The next one is this one here. So this one, we need to make sure that we squeeze one cos shape from 0 to pi. So here's 0 for x, and we're going to make that shape happen from 0 to pi. So basically, all of these x-intercepts are going to be shoved in a little bit closer. So pi over 2 times a half gives you a quarter, so it gives you 1/4 pi. So basically that's what's going to happen. This one over here is going to go to there. So it's going to look like this. And that would be good for a sketch. So this is cos 2x. Okay, so you can see it's happening from 0 to pi. Now sometimes you see here it says draw from 0 to 2 pi. So I got to do that again. And I do my best here. There. So you get 2 cos shapes from 0 to 2 pi, and you get 1 full period from 0 to pi. Awesome. Last one was in blue. All we're doing is we're subtracting 2 units from the original cos function. So let's scroll down a bit. So this one is going to go 1, 2. This one here is going to go 1, 2. So that's the point at pi over 2. This one here is going to go 1, 2. So there it is. This point here is going to go 1, 2. There, I think something is wrong here. This one went down there. Right, I was looking at the wrong spot, I think. So this was the next one. So it should be going 1, 2. No, I was okay. There we go. Sorry about that, you guys. And just getting really hard to read here. So at pi, we should be down here. So that was fine. What did I mess up then? 3 pi over 2 was down here, so it goes, oh, here it is. I'm looking at the wrong one. So 1, 2, so it's there, and then 1, 2, it's there. Something seems royally messed up there. Let's see what I can do here. Something's wrong. This point should be down here. The point at pi. Yes, so my mistake. That point is not there. So the point at pi, right here, so it's down here, it goes 1, 2, perfect. There we go. So now this is going to be -3, this is -2, this is -1, just to be clear, and there you have it. There's cos x minus 2. Do not do more than 1 graph per graph would be my suggestion. That was a nightmare. So just to recap, from -1 to -3, all those points shift down 2 units. There it is. Hopefully it's easier on your page. Mine was pretty messy looking. All right, I think we're basically done. There's a whole try it yourself. And what I did is I put the answers down below and I flipped them upside down so it's a little bit harder to see. And if you want to check your graph, just go to desmos.com and you can graph them there if you want to check. You are ready to do 6.5. Good luck, and we'll see you next time. Bye-bye.